So this, I guess you might say this unit is about graphing on the Cartesian coordinate system, the x, y axis.
My biggest fear.
Do what?
My biggest fear.
Your biggest fear. Not too. We're not getting too involved. If you take the college algebra, Math 136 class, you know, it's all about graphing. I guess you would say, but anyway, that's in the future. This is what we're talking about here is mainly graphing lines. I guess that is what we're talking about, graphing lines. And so, yeah, it mentions that the graph of linear equations requires two points, because you're graphing lines like 2x plus 3y equals 12. It's a line. And the other one, the other form that we'll see is y equals 4x minus 5. Yeah, those, if you graph those, you get lines. They're linear equations. And that just means the powers here are one powers. If you get something squared or square roots, then you're looking at a different shape. But we're talking about graphing lines, and so that's what he mentions: linear equations in two variables. And so those are basically the two types that we'll consider today. But anyway, the thing about lines is, one of the things is, okay, so we graph a line, get 2 points on the line. Let's say we get that. Graph another line, comes in like that. Well, obviously, they're slanted differently, right? And one other thing, so let's say we've got another one that's slanted uphill like that, but okay, like that, all right? Much steeper. So my point of all that is to mention, so what unit of measurement do we have for describing how it's slanted and whether it's steeper or less steep? That's called the slope, isn't it? The slope is the measurement of the slant and steepness of a line. And the way it works is, of course, uphill is positive slope, and downhill is negative slope, and we'll talk about that. Show that in just a minute. And then, of course, this one's steeper, so guess what? The slope is larger, so that would have a larger slope than these other two, relatively speaking there. Now, a couple of other things we know slope by, and that is, one of the things we know it by is, that'll help us, is the actual measurement of it, I guess you might say. To get that slant and steepness, what you look at is you look at the rise of it to the run that it has. And all that really refers to is the rise is how much it goes up, straight up, and then the run is how much it goes horizontally speaking. And so those numbers, rise over the run, let's just say that's 5 and that's 2. That gives me my slope. So that would have a slope of 5 over 2, 5 halves, 2.5, if you want to put it into a decimal or whatever. But that's how the slope is calculated, or one way we can use the slope. Now, what we also would want to notice, or another way we know slope, so the rise, So this is the y-axis, right, and this is the x-axis. So the rise is what happens in the y direction. And so sometimes we say the rise is the change in the y, whereas the run, which would be this amount, is the change in the x. So just trying to give you, because we haven't really done anything, or so far this is just kind of preliminary information here, because what we want to do, what it will have us do in the problems here, is actually calculate some slopes. And so that's all tied into then, now I'm at kind of that second line there. The slope of the line, because it is rise over run, changing the y over changing the x. If you've got 2 points on this line, let's draw another line here. And we don't know, I'm not going to put any scale on it or anything, but all we know is this point is x comma y. You know, a point is an x comma y ordered pair. And so that's going to be our first point, so x1, y1, that's over here is our second point, so it's x2 comma y2. And so the slope formula, based on all that, is, okay, and then the other little notation is, in case you didn't know, M is the letter designation for slope, right? And for whatever reason, they call it M. But it's, since it's a rise over run, change in y over change in the x, yeah, so if we have x's and y's to work with here, 2 points, the slope is you take the second y minus the first y. That gives us our change in the y. Second y minus first y. And then the run, the change in the x, do the same thing for the x's. And so that is the so-called slope formula. So let's find the slope of the line. This one's not in the book here, but find the slope of the line. Let's see, I was going to do 2, 1, and 5, 8. Slope of the line that goes through, what did I say, 2, 1, and 5, 8. Well, it's just a matter then of plugging into that formula. And like I said, it's really, you know, looks like a complicated formula there, but all this means first y, second y, first y. So you take your second y, which is 8, minus the first y, which is 1. Second x, 5, minus first x, 1. That gives you your slope. And in this case, that would be 7 over 4. So that line has a slope of positive 7/4, so it would be an uphill line. If we graph those out, I guess we could real quick here. So 2, 1, and 5, 8. Yeah, there you go. Positive 7/4 is the slope of that line. So yeah, it's uphill. Positive lines have uphill slope. Now the other thing mentioned there, I'll talk about those other, has some, don't forget, following slope notes. We'll talk about those later on. But let me skip down there. So based on the Pythagorean theorem, also, since we're doing 2 points here, also we can do what is called the distance between 2 points. And it's based on the Pythagorean theorem, a squared plus b squared equals c squared. It's kind of like a tack on here, because since we've got 2 points, yeah, distance between 2 points formula is that. So yeah, if we want to calculate the distance, let's just think about this. So if I want to know this distance right here, we'll call it D. Turns out that distance is the square root of, like I said, it's based on this, Pythagorean theorem. We talked about that. We had a couple of problems we used that on last unit. But yeah, it comes out of that because if you solve for C there, it's basically this, and you've got a right triangle right here. You do that. So anyway, not going into all the fine details there, but that's where this comes from. So it's, yeah, it's the difference of the x's squared and the difference of the y squared. So it's x2 minus x1 squared plus, that gives you this distance right here. Distance. And then the y2 minus y1 squared, that's kind of your, call it your A and B. So the A is x2 minus x1, the B is y2 minus y1. But anyway, this is the formula, okay? And so you can use those to find that distance. So let's go ahead and do the example, middle of the page on 23 there. Wants us to find the slope and the distance between 2 points. So we've got 2, 3, and 1, 5. So number one, find the slope of the line that passes through those. Yeah, so that's our slope formula, m equals y2 minus y1 over x2 minus x1. And so that just means second y, 5, minus first y, which is 3, over second x1 minus the first x2. So what is that, 2 over negative 1? So yeah, that brings us to the point. Yeah, this is just a number, really. You can consider that your rise over run, but really we need to simplify that. 2 divided by negative 1 is negative 2. So this slope is negative 2. And so what would that mean, uphill or downhill?
Down.
That's going to be downhill if we graph those 2 points. And so then number 2 is the distance between those points. So that's that formula, D equals the square root. So it's x2 minus x1 squared plus y2 minus y1 squared. And so that gives me what? So the x2, so this one we start with the x2, so it's 1 minus 2 squared. Plus second y, 5 minus first y squared, so it'll be 5 minus 3 squared. All right, and so that gives me the square root of negative 1 squared plus 2 squared. And the deal on that is you've got to square those and add them together before you square root them. So negative 1 squared is 1, 2 squared is 4. Yeah, so you've got to add those together before you square root them, which go ahead, so on the homework, what I'd like for you to do, go ahead and, get the square root of the distance in terms of the square root, but also go ahead and calculate about how much that is, round that off. Let's do it two places. So what do we get? Let's see, square root. Never remember. I have so many calculations. All right, square root. Where are you? Oh, there it is, okay. Square root of 5. 2.224, okay? So units wise, between those points, a little over 2, almost 2 1/4 units. So give both of those if you don't mind there on these problems. Now, I wanted to do one more before we move to the other part of this. Okay, same thing. We've got 2 points, -1, 6, and -4, 2. So that's 2 points on a line. All right, so number one, what is the slope of that line? Yeah, the thing is, with the negatives, you got to be careful with your negative signs. So the slope here, y2 minus y1 over x2 minus x1, what is that going to give me? Well, y2, -2, minus y1, 6, okay, no problem there. x2, -4, minus -1. Now, why do I have a minus -1 there? Well, this minus is from the formula, and this minus is from the actual value, right, of the x. So we've got the old double negative. What happens on the double negative? Well, 2 negatives in a row like that make a positive, so you actually wind up adding 1 on the bottom there instead of subtracting. Let's finish it out here. So -8 over -3. What about that? Well, you got negative divided by negative, so that's also going to be a positive. So this one's going to have a positive slope, it turns out. Even though there's lots of negatives there, but 8/3, 2 2/3, if you like. That's a reduced fraction, so that's probably how we would see it listed, but there are other options there. All right, then the distance, same thing on it. Well, distance, so we take x2, -4, minus x1, so that's our double negative again, square that, plus y2, -2, minus y1, which is 6 squared. What does that give me? Again, negative makes a positive, so that's -4 plus 1, so that's -3 squared. -8. Square that. Squaring them both, so they both turn into positives. So it'll be 9 plus 64 squared is 73, which is an exact answer, I guess you might say. Square root wise, what is that? Not quite 9, 8.5, something like that. Yeah, 8.54. All right, is that okay? Question or concern?